Hi everyone, so we're going to do a redo of the ScanSolve tutorials that I had on previously because I now have new updates from the developers. So first thing first is we're going to do something that we've kind of covered in Rhino, but is to verify that your units of your model and your model space are correct. So with this one, make sure that you have your modeling units in inches if you have a relatively small component. And then make this at least 5 floating decimal points. So the precision and the intersection of the two types of planes and well, generally any type of intersection can be detected more easily. Then change this to feet and inches and drop this down to 1/32 at least. So then when you enter a measurement in, if it's at least within the range above this, that it can be entered in properly. Anything else that you have other than this is going to cause for the inability of Rhino to detect the intersection cleanly and might cause some problems of you not being able to project geometry or whatsoever. So hit OK, and then have a general idea of the size of the element that you're working with. So if you type in distance, this one is about 3 by 3, so it's about a square, but it's a relatively small component. The reason we need to know this is because the force that you apply to it needs to be kind of relative to the size of the component that we're dealing with. So once you have this, there is some suggestions covered in the Scan and Solve website, which I've sent out to you for the loads. That's been updated from the one I had previously shown you. What we're going to cover today is a vector load, or a surface load with a vector that's going to be on a partial face of the component. This is covered here of how to split part of the surface to apply a force just to an isolated area, which is more similar to what we've been working with within the components as if you were to push down on the apex of this one. So I'll show you that today, but in case you need other types of force or loads, you can check out the 4 types here. You have surface, vectors, vector, scalar, pressure, and torque. And then we have these options explained below. So you can get in some quite interesting load analysis, but for what we're doing today, we're just going to work with the vector force in the negative z direction. So first thing we need to do is isolate the faces that we're going to push onto. I'm going to just draw a circle and project this down onto the surfaces that I have here so that I get an interpolated curve upon that surface. So if you look at this, I now have a curve that's on that those polysurfaces, but because they're polysurfaces, I'm going to extract the top surface that would intersect with this and split it based off of this curve so that these surfaces are then independent. So now if I type in select curve and delete all the curves and then select all and join, I will see that I have one closed polysurface, and this is what we need to work within Scan and Solve. If you type in what, you will detect the closed polysurface type object. Also, if you go into your standard and properties, you'll see that it's a closed polysurface as well. If it doesn't read as a closed polysurface, you can go up to Analyze, Edge Tools, and Show Edges, and then your naked edges, if you add your object, will be displayed in pink. And then you need to close your object based off of these naked edges. So once you have a closed surface, then if you go over to your Scan and Solve tab, we're going to assign that solid into our program. And then I've also sent out a wood text file that was provided by Michael and Vadim. If you go into custom and go to import, then you can navigate into your file of where that text is and then load it. Once it's loaded, you will see that in the drop down you'll have wood options: wood, black cherry, white oak, and white pine. We're going to go with the white oak for today. And then we're going to add some restraints along the edges. If you click here, you can add it to a surface or an edge, and we'll do the edge condition along these 3 edges. And then for the load, we're going to apply it to these top surfaces to simulate a push or a force down on that apex. And then for the vector force, we're going to do 0, 0, -10. For 10 pounds of force, that will be going down in the z direction, and hit OK. And then for this, we can just hit go, And I'll run the simulation. And then once it's completed, if you go into the View tab, we'll be able to see the kind of analysis that was run. So if we go over and pull down into the total displacement, we'll see a magnification of the deflection of this type of surface, of these surfaces. So if you stay within total deflection, you also have the option to create a sectioning plane that can show you the cross-sectional properties, and you can drag this along your component to see the conditions. And then in the Y, and then in the Z, we'll show you a planar view. If you flip this, it'll also show the mirrored version of that, so you can see a cross-sectioning plan view that would go down throughout your element. I'm going to turn off the sectioning plane for now and go into advanced. And then I'm going to pull down to the max principal stress that will show us the principal tensile stresses. So I'm going to pull this legend to here to show more contrast, and then I'm going to change the minimum to be a 0. And then I'm going to move the max deflection into the non-blue areas so that I can see the red areas, which are relatively more tensile stresses. And this is a magnification of what's going on within the structure. Obviously, at its initial state, you may not see this type of displacement or stress, but we want to understand what's going on inside of it, or within the simulation. So with this, we can also see the magnification of the deflection as well. And then you can bake this report, or bake this output as a RhinoMesh object, and then also, or any of these. I think I've only selected the RhinoMesh object with you guys. But let's go through one more of the component stresses. If you do the minimum principal stress, this is the regions of compressive forces. So if we change this legend and then also change the max to 0, and then take this and navigate it into areas that have a blue any areas that have non-red, which, wait, this is 0, we need to put it this one. Yes, so when we start to get the non-red, this is areas of regions of compressive stress. So as we're pushing down there, this makes sense because we have the compressive forces emanating from that top kind of force. Alright, so let's just cover how to output this for some use. As I said before, if we bake this, navigate to where you want it located, desktop, legend, yes, and then hit OK. It'll give us a mesh object there, and if you right click on this and change it to rendered, you're going to get that as an actual object that you can see the material on. Then I would also suggest that you print screen this in order to get these ranges that you have here, and also see the max principal stress. If you change the deflection scale up, you'll see this magnitude that you're working with here and the magnification of that stress on the object. And then that is pretty much it for now. Hopefully I will have more for you guys to work off of in the future, but for now, here's just 2 simple ways for you to work on your objects.